20% from IC region, 80% from battery pack, then we are able to achieve 69% efficiency, conversion efficiency, the operational efficiency basically of this system. So what the meaning of this one? Yes, it is possible. Let's say suppose that the previous case IC engine was giving 100 kilometer in 10 meter. This time it is possible to have same distance in something around 3 meters, 3.5 or something, 3 meters. It will be possible to get that. So this is the advantage. So this says that we are able to reduce the emissions which are which have been contributed by the earlier vehicle. Now, a minor drawing for that results in the overall. What are the different types of power electronic converters which are required here? So, like rectifiers are needed, then the motor is needed, DC to DC converter is required, and then this is that because a DC to DC converter. That I use the term energy sources and power. And what is the difference between the two? Energy is difference between energy and power sources. So energy sources basically those sources which are capable of delivering nominal current to an vehicle. They are, for example, battery. Okay? With battery, your battery will be able to give you 100 ampere continuously for 3-4 hours. Okay, 3-4 hours you will be able to, maybe like you are running the vehicle like 50 kilometers per hour and in continuous 4 hours, you are able to run your vehicle for 200. So that depends on the capacity of the battery. But yes, what is the capability we are observing? We are observing that our energy source is, for example, battery is capable of delivering 100 ampere of current continuously for a long duration. And whereas the power source, this power source cannot deliver that much of high current. For an example, when we are accelerating, whenever we are going to accelerate, at that time we need to exert 2 times the rated torque. Okay? 2 times the rated torque. So, for example, what is the meaning of this one? In conventional suppose that we are trying to draw 100 ampere of current for continuous running, when you are going to accelerate your vehicle, you will be drawing 200 ampere. So, this source, energy source, will not be able to deliver you instantly. Okay. Or if they are delivering at the cost of their life. So, but there are some sources like power sources you will see that they are capable of delivering just 200 ampere of current in a very short duration. For the wheel, at that time it will 10 to 20 seconds. Only that, not more than. So, with the power sources, you will not be able to handle. You will be able to meet only the transient. So, I hope that you understand what actually is the energy source and power source. And of course, when we say energy source, we are going to represent them in kilowatt hour per inch. That is an absolute scale. That source we represent them as kilowatt per kilowatt. Let me go ahead further. So, what are the different energy source? Battery, fuel cell, photovoltaic panel. What are the power sources? Supercapacitor, flywheel. Then you can see here that just a moment. Then different power electronic converters for the charging meters. At present, I am just talking about the power electronic converters. Okay, here I did just we saw that rectifier, inverter, DC converters, like this. Similarly, for the our charging infrastructure, we have conductive chargers, then wireless chargers. These are the things which are there. Just what is the problem? Just so you can see that here you are able to see the 2 different chargers. One is called conductive charger and another is called wireless. So these 2 are the development in our lab. This is the wireless charger, what we have developed, and this is a conductive. You can see here again power electronic converter is here. So some is like one is power factor reduction rectifier, and then we have a buck converter. Similarly, when you see that when we talk about the wireless charger, we have power factor correction rectifier, and then XPG inverter, and this rectifier. So I just explained you one by one. First, let me explain you what is the necessity of when we work into wireless charger, any charger, what is the necessity of this power factor correction? You remember that we receive energy from the grid. So what is the nature of the voltage? This is sinusoidal voltage. What is expected? Expected is that the current should be so that we should maintain limit. So whatever the kilowatt is required, we should deliver on. We should not draw excess energy from the circuit. Let's say this is supply voltage, and this is supply voltage, and this is. But in practice, what happens? So often we don't use this rectifier. Yes, we don't use this one. So what is going to happen? I'm able to see this battery. Basically, mostly the batteries are charged with constant current charging. Means you are trying to inject a constant current into the battery. This is very important principle. So this is a constant current you are trying to draw. So this is basically turns out as a different element. You see that this rectifier was there. So here, I just try to explain. So when you see a charger, we have 8 point, and then basically what we do, that connect a voltmeter. Here basically, right, with the meter compensation. Okay. The like capacitor filter connect, and then we are having it. And here is the non-point. So let's for the time consider that this, for the time we will consider that this is not it. So, and here we are trying to inject a constant current into the battery. That means we are operating our charger in constant current. So this will reflect as here R but here like IV inductive is connected here. IV inductive. When you start, if you transfer this resistor to this, what is this resistor? Let's say this is a battery, okay, and I back. So what is the equivalent resistance of the battery? Okay, battery. Okay, I. So you transfer this resistance. So our idea is not to consider this here, but remember that we are taking current. This makes this one to be like an inductive, high inductive. We try to draw constant. Means, you see, this is rectified, and here the supply is sinusoidal, here the supply is something. We are rectified. So, what happens is that this arrangement make your rectifier that are load by because of that, what happens? That what the supply current is here, and this is the supply voltage, this is supply voltage, and this is like that. You see that this is not same as that was our requirement was something like this. Our requirement was something like this. Our requirement was so here you see that now this is a square. So we know that this is a square root. So we have third harmonic component 2, 3, 7, 9, 11, and all those all harmonic components will come. So what is going to or is unelectricity. And if all some nodes are connected here, then they will also get affected. They will not work. This is not. So it is always compulsory for us that if the charger is there, we must have a power factor connection. So you don't use only this rectifier, rather this, like one of the solutions is rectifier to give the DC boost converter, which is called boost. Other are active rectifiers, then with inner rectifier is there. So this is your DC bus. If a charger is there, 400 volts, single phase. If it is any phase, it could be anything, it could be 750 to 800. Means it could be anything 690 volt 800. That's and then after this charger. So this power factor correction is must for us to help in our. So this is